Welcome back. We are finishing up today, our inequalities and equations with absolute value. The first day we talked about equations. The second day we talked about ones that were greater than. And so today we're going to deal with inequalities again, but now we're going to talk about our less than ones. So kind of my notes here down at the bottom, we're just continuing on. Less than. So I'm going to write in big capital letters again, less than. And less than are going to be actually ands. And we'll talk about that in a second. And I call this L and then and I refer to these as lands. So if you can remember that kind of as a little trick. So when we deal with less thans, the mathematical language, and of course there's more to it, I just kind of going to highlight what we need. So they say the absolute value less than b, where b is greater than 0, then solve negative b is less than a, which is less than b. So what I want you to do is I want you to look. Let's make these orange today. For less than, they're ands, they're lands. Notice what you've got going on here. You've got a less than sign this time. And then notice what they do. They take and they make a negative b and then a less than sign, and then they drop the absolute value sign and copy everything over. So that's kind of what we're going to write. So here are kind of the steps. There's just one to do, or there's just one way. You don't split it up into two because it's not an or. So you change the b, this part right here, to a negative. You add another less than sign. And 3, you drop the absolute value signs. And copy the rest over. Okay, so you copy the rest over. All right, so let's see what this looks like. So number 1, absolute value of y minus 5, which is less than or equal to 2. So again, I'm going to highlight in orange. This is a less than. So it's less than. So that means I'm going to make it an and. And to remember that is land. So gore and land are my two little things. So less than, it's a land. So in order to do that, here are the steps. So here are the steps right here. So step number 1 says change the b to a negative. So this is the b. So I'm going to change it to a negative. So I'm going to make it negative 2. Then it says step 2. Add another less than sign. So I add a less than, and this happens to be an equal to from the original. So I'm going to do the exact same sign, less than or equal to. And then step 3, drop the absolute value signs and copy the rest over. So then I'm going to take all of this, I'm just going to drop the absolute value signs and copy it over. So y minus 5 is less than or equal to 2. And you have to just memorize those rules. That's what you need to do. All right. And now what you can do is just solve. So you add 5 and you add 5 and you add 5 to all 3 parts to keep it balanced, to isolate the variable inside. Negative 2 plus 5 is 3, which is less than or equal to y, because those cancel, which is less than or equal to 5 plus 2, which is 7. So if you were to graph this, and again, I'm not real concerned with graphing because you guys are pretty good at it, but what you're going to do is you're going to have a closed circle at 3. You would have a closed circle at 7. And you graph everything in between. So like that. A land, a less than, an and. Okay? So again, this only happens with absolute value inequalities. So now you have 2c minus 5, which is less than 9. So once again, it's a less than. So I'm going to make it a land, an and inequality. And remember, ands, are the ones that meet in the middle. So in order to do that, you take the b, that's right there, that 9, and you make it negative. You take the same sign, which is right there, you copy it over. And then you drop the absolute value signs and you just copy the rest. Not changing it, keeping it exactly the same, except you just drop the absolute value signs. All right, now we got to isolate just like we did in inequalities. So that gives you negative 9 plus 5, which is negative 4, which is less than 2c, which is less than 14. Divide by 2, divide by 2, divide by 2. And so that'd be negative 2 is less than c, which is less than 14 divided by 2, which is 7. So, dun, da, 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 that's my answer. I guess I should have circled that one up there too. There's my answer. Okay, so let's try number 3. Now I'm going to take it up a notch. Let's see if you know what to do. So absolute value of 2x minus 7 minus 1 is less than 0. So what do I have to do here, knowing what you know from all the absolute values that we've done before? Hopefully you're telling me, isolate first, and you're exactly right. Right here, I need to isolate, okay? So I need to do that first before I rewrite anything. Whoops. So I'm going to add a 1 to both sides to isolate first. So absolute value of 2x minus 7 is less than 1. Okay, so now I have a less than, so I make it an and. So I take this b right here and I make it negative. I take the same sign that I had before and I write it down. Then I drop the absolute value signs and copy everything else exactly the same. But remember to isolate first, okay? So isolate first. So I'm hopefully you picked up on that. All right, so now I solve. I add 7, I add 7, I add 7. And that gives you negative 1 plus 7 is 6, which is less than 2x, which is less than 8. Divide by 2, divide by 2, and divide by 2 in all three parts. So 6 divided by 2 is 3, which is less than x, which is less than 4. All right, last one. I'm going to throw you a little bit of a curve. Hopefully you know what to do. So this one says 9 is greater than absolute value of 6 plus 3x. What do you think? Are you saying, oh, I know. You need to put the absolute value on the left. Hopefully that's what you said, because you are exactly right. Put the absolute value on the left. So I'm going to flip-flop this, and I'm going to say 6 plus 3x. Now, again, the 9 is the bigger number. Less than is kind of going here. So make sure you kind of, when you flip-flop it, you keep the sign pointing to the greater one, or eating the greater one, however you want. Okay, and now that you can see that, I have a less than symbol. So again, we're going with land. In order to do that, you take your 9, you make it negative, or the b, make it negative. Keep the same sign. Now drop the absolute value and copy everything else over. Okay, so go ahead and subtract 6, subtract 6, subtract 6. So negative 9 minus 6 is negative 15, which is less than 3x, which is less than 3. Divide by 3, divide by 3, divide by 3. So you have negative 5 is less than x, which is less than 1. And there you have it. All right, so now, last but not least in this lesson, those are my less thans. Now we need to talk about when you see real world situations. And so that is what we're doing next. That's what I'm moving to. And I have some story problems, and I saved them for today because these are going to end up to be less thans, always, always, always. And so we're going to make them into lands, or less than ands that we just did. So this is kind of one of those real world situations that definitely come into play. And maybe you don't know, but they would use these absolute value inequalities a lot in manufacturing places. Picture yourself like going down the cracker aisle at Meijer or at the grocery store. And you know, you've got boxes of Ritz crackers and Club crackers, and you've got Cheez-Its, and you have all of these like pita chips and all these fun little cracker boxes. Well, those cracker boxes all have a certain amount of weight in them. Now, do you think every single one of those cracker boxes are exactly the right weight, identical? Do you think somebody sits there and counts out that it needs 32 Ritz crackers every single time? Probably not. A machine does that for us. And what we do is you have to program, what they do is they program the machine to give that box exactly what they need. And so what they do is they program a rule into the computer at those manufacturing places. And the rule is always this: absolute value of X minus actual weight, and definitely get this down, is less than or equal to what it varies by. So this is something that you have to memorize. You have to know this rule, and it gets set up like this always, always, always. So it says a pasta manufacturer makes 16-ounce boxes of macaroni. The manufacturer knows that not every box weighs exactly 16 ounces. The allowable difference is just 5/100ths of an ounce. Write and solve an absolute value inequality that represents the situation. Okay, so here we got 16-ounce box of macaroni. They know that they don't weigh exactly 16 ounces, and the allowable difference isn't a lot, but it is 5/100ths of an ounce. So what you do is you take this rule that I just wrote up here, you take the absolute value, you use X, it's always a subtraction, and then you find the actual weight. Well, right here is the actual weight. So I'm gonna highlight this. I think I'll highlight this in pink. So the actual weight right here, it says right here that it's 16 ounces. So then I'm going to put 16 here, and I'm gonna highlight it in pink so you know what I'm doing. Okay, then it's always a less than or equal to, always, always, always. This is the rule, always. And then we go with what it varies by. And let's put that in yellow. We haven't used yellow lately. It's a 0.5 is what it varies. So the varies is 0.5. 500ths, 0.05, 500ths. And so that's what it varies by. And that's what you do is you plug it in every single time. Now, as you see, this is a less than right here. This is a less than. So that makes it what we just did, which was a land. And I know that's kind of hard to read, but that's a land. Maybe I erase this. Let's erase this. Oops. Kind of got my sign. And it's always a less than or equal to. Always, always, always. So this is a less than. So it makes it an and. Or a land, okay? So what I do is just like we just did. You take that B and make it negative, so negative 0.05, and then you add a less than or equal to symbol, exactly what you have, and then you do X minus 16 is less than or equal to 0.05. Copy every single thing over. So then I'm gonna solve just like I would do before. Add 16, add 16, add 16. So it would be a -5 plus 16, which would be 15.95, is less than or equal to X, which is less than or equal to 16.05. Meaning that box of macaroni has to be between 15.95 ounces and 16.05 ounces. If it's not, then they send it back. So that's what they're guaranteeing when you buy a box of 16-ounce pasta, that is going to be between that range. So, and again, just like with story problems, we need to describe. So the pasta box weighs between 15.95 and 16.05, throw in what we're talking about, ounces, and then I'm going to throw in the word inclusive, meaning we include 15.95 and we include 16.05. And they all get solved that way. So let's look at the next one. One brand of crackers should weigh 554 grams. The quality control inspector randomly selects boxes to weigh. They do this at manufacturing. They select it and they check it out to see if their machines are working properly. The inspector sends back any box that is not within 5 grams of the ideal weight. Write an absolute value inequality that represents each situation. What is the range for allowable differences for a box of crackers? So Again, they all get set up the same way. Absolute value of x minus. Now I need the actual weight. So let me change to pink. My actual weight is right here, 454 grams. So 454 grams. That's the actual weight. I'm going to highlight that in pink, which is less than or equal to, and now I need to get what's the allowable difference. And the allowable difference, they said, is it has to be within 5 grams of the ideal. Okay, so that's how much it varies by, within 5 grams. So I put a 5 there. Okay, once I have that, I see that this is a land, so I'm going to make it an and. In order to do that, I take the b and make it negative. Take the same sign, less than or equal to, and it's always less than or equal to for these. It's going to be x minus 454, which is less than or equal to 5. And now I solve. So I add 454 to all 3 sides. And I have negative 5 plus 454, which would be 449, is less than or equal to x, which is less than or equal to 5 plus 454 is 459. So the cracker box will weigh between 449 and 459 grams, and then the word inclusive, meaning including, okay? And there you have it. All right, last one. This one I want to bring up. We're not going to actually solve it, but I want to bring it up because it's a poll and it's percentages, but we solve just the same. It says one poll reported that the approval rating of the job performance of the President of the United States was 63%. The poll said to be accurate within 3.8%. What is the range of actual approval ratings? So they said that his job, they were doing it within 63%. So 63% is there. That's going to be our actual. And then it said it would be accurate within 3.8%, which it varies. So now the only thing you have to know when it is in percent is that you have to change these into percentages. So actual weight, take a decimal and change it into percentage. I move it 2 times to the left, so it'd be 0.63 because I can't use it as just a straight up percent. I have to change it into a decimal. All right, is less than or equal to, and then what it varies by, and that's going to go here. And same thing, I can't leave it as a percent. I need to move it to the decimal, which means 2 places to the left, and that'd be 0.038. And once again, you have a less than, so then you can set it up as an and. Take the negative, so you would have negative 0.038 is less than or equal to x minus 0.63, which is less than or equal to 0.038, and you would solve. I'm just not going to take the time to solve it. Okay, so all of these happens a lot in manufacturing for sure. They follow that rule, so you just have to plug in and remember that rule.